10 things I wish I knew in college. A mechanical engineer's journey. I graduated with a BSME, Bachelor of Science in Mechanical Engineering, from UT Austin in December 2005. Over the past 2 decades, I have had the chance to go to graduate school for MSME, work in the industry as a design engineer, and as an engineering analyst. I have worked in customer-funded R&D, research and development, and government-funded scientific and engineering research. I have had significant exposure to academia as well. Needless to say, I have learned a thing or two about mechanical engineering from my experiences. When I look back to my time during my undergraduate days, I feel, if I knew then what I know now, I would have approached my academics and career in a more focused and efficient way. I have been incredibly fortunate to have ended up where I am now, but had I been more informed in my younger years, my career path may have been quite different. What follows is 10 of the most significant pieces of information which I think would have benefited me immensely back in 2002. I hope that some of you will also find this information useful. Number 1, proper guidance is more important than you might think. I come from a family where engineering, of any type, was never the field of choice. When I applied to university, I literally did not know a person in my extended family or circle of friends who I could talk to get some information and guidance on engineering in general, and mechanical engineering in particular. I think it is extremely important to gain as much information about your selected area of study as you can before you apply to it. Yes, you can look things up online, and yes, you can always change majors after you have applied. But in my opinion, nothing beats direct advice from those who are qualified to give it. It might save you a lot of time and frustration if you seek out a number of people who are experienced in their fields, even senior undergraduates or graduate students, and pick their brains. Learn as much as you can so you can be efficient and decide and plan accordingly. Number 2, your undergraduate advisor may not necessarily be the best career guide. Generally speaking, undergraduate advisors are good academic advisors. They are not necessarily fit to provide you the best advice regarding your career. One might argue that thinking about career during your undergraduate days is premature, but I would disagree. Knowing what you are pursuing in life can absolutely influence your academic path. From the courses that you take, to your ambition for graduate studies, to your inclination towards research, all of this can and should be affected by what you plan to do after you graduate. My point is, talk to your advisor, but be aware that they might not give you satisfactory answers to all of your questions. If this is the case, you may want to seek out other people who could guide you better. Number 3, as a field, mechanical engineering is much broader than you might think. I think the first things that come to most people's minds when they hear mechanical engineering are machines, tools, mechanisms, and moving parts, pulleys, gears, pumps, compressors, etc. This is understandable. In some ways, mechanical engineering has been around for longer than any other form of engineering. The Stone Age man designed tools for hunting and devised techniques for survival. Most of this activity could be classified as mechanical engineering. More recently, the discovery of electricity was immensely significant in shaping the future of engineering. In the pre-electricity days, most engineering was consistent with modern definitions of mechanical and civil engineering. But over the past 300 years or so, mechanical engineering has evolved from being a tools and machines field to something which is much broader. Today, the mathematics that helps you understand fluid flow through a pump also explains blood flow through arteries, the lift of an airplane, and the drag force on a golf ball, all varying applications of fluid mechanics, which is part of mechanical engineering. The way I look at it, where there is matter, there is mechanics, and hence mechanical engineering. When we say matter, we imply matter that can be studied by classical, Newtonian mechanics, as opposed to the study of matter involving modern fields, such as quantum mechanics. Number 4, identifying what you are naturally good at and not good at goes a very long way. Sooner or later, most people figure out the academic areas and the professional or non-professional fields which they are likely to enjoy and excel in. In other words, most people discover what they are passionate about at some point in their lives. Passionate enough to turn it into a career, It must be said that when we say most people, we imply most privileged people. Indeed, being able to choose the means to make a living is a massive privilege. The majority of the people in the world would be glad to just find a way to make ends meet. With regards to mechanical engineering, it is beneficial to identify if you would like to get into mechanics of materials or thermal fluid systems. Do you enjoy work that is very hands-on or something that involves a lot of number crunching? Do you like to look at minute details or prefer a bird's eye view? While it might not be possible to answer all these questions in your freshman year, it is best to start thinking about them early and to narrow down your focus. Within mechanical engineering, one might be able to take advanced elective courses that are in line with their preference and could also help them later in graduate school or professional career. Number 5, calculus, calculus, calculus. When it comes to the theoretical aspect of mechanical engineering, the role of calculus cannot be overstated. Calculus acts as a foundation to most high-level mechanical engineering courses. Other fields of mathematics, for example, linear algebra, are also important, but the depth and breadth of applications of calculus can be overwhelming. Basic courses in calculus, Calculus 1, Calculus 2, differential equations, act as prerequisites to many advanced engineering courses. Paying attention during these courses and strengthening your calculus foundations will have a direct impact on your future studies. This is even more relevant if you wish to pursue master's studies in mechanical engineering. In fact, I am of the opinion that a lot of the advanced level courses in mechanical engineering are virtually indistinguishable from courses in applied mathematics. Now, a lot of people might argue that, oh, you will literally never use calculus even once after you graduate. And this may be true for many people, and not true for many as well. A lot of design engineers will rarely need to use even fundamental techniques of calculus during their jobs. But still, I believe the concepts learned in calculus can act as great assets in the arsenal of a mechanical engineer, regardless of how frequently they need to apply them directly. Do not take calculus lightly during your freshman and sophomore years. Study it, learn it, understand it, and know it as a language so you can apply it as and when needed. 6. Classical physics mechanics is a great complement to mechanical engineering. One of the definitions of engineering can be the utilization of the principles of nature to benefit mankind. The principles of nature, or science, is what sets the foundation of engineering. With regards to mechanical engineering, classical physics, especially classical mechanics, quite elegantly fits the definition of the principles of nature. I like to say that mechanical engineering is to engineering what classical physics, mechanics, is to science. For these reasons, it makes sense as an undergraduate student to either minor in classical physics with a focus on mechanics or take physics courses that complement mechanical engineering studies. Number 7, you do not learn how to design at school. You learn it at the workplace. Engineering theory and engineering design can often be two very separate entities. Yes, there is implementation of theory and design. Yes, you also take a couple of design-focused courses during your undergraduate studies. Machine components design, final design project, etc. But at the end of the day, some of the fundamental skills required to come up with a good design are not taught at school. In fact, some of the skills cannot be taught in a structured setting at all. The ability to visualize 3D objects in your head, the tendency to figure out how things assemble together, having a good feel for how heavy or big something is, being able to view simplicity in complex scenarios and anticipating complexity in seemingly simple situations, are all essential skills to excel as a design engineer. And none of these can be taught effectively in a classroom. These skills are utilized and improved through experience with designing components, which happens at the workplace. If you look at the human population, these skills exist on a spectrum. One might argue that people who choose to study mechanical engineering are those who already possess high levels of these skills. Sure, we call this aptitude. This is very true, but even within mechanical engineers, these skills will exist on a spectrum. Engineers will lie anywhere on the spectrum. Perhaps the majority will lie towards the higher end. Some engineers will struggle with design, while to others, design will come very naturally. This is not to say that those weak in this aspect cannot excel in their careers. Not at all. It is just that they might have to work harder to actively and passively acquire these skills during their professional endeavors. For some, it might be a long journey, while for others, it will be like second nature. This is just life. If you are a mechanical engineer, but not a natural designer, do not be disheartened, but be cognizant of your challenges. Know that you have options, from improving your design skills through gaining experience and hard work, to pursuing a side of mechanical engineering which is less design-focused. Number 8. Once you get a job, you may have to give a lot of presentations, some presentations or zero presentations. Communication is a major part of most engineering disciplines. Mechanical engineering is no different. I think it is fair to say that most mechanical engineers would be expected to give regular presentations in front of groups of people. Depending on the goal, the frequency and content of these presentations, and the size and makeup of the audience would vary. Generally speaking, presentations given to customers or parties external to your company are more formal and demanding. Those given to internal customers, such as company sales, a group of colleagues, status updates to your manager, etc., are usually less formal and put fewer expectations on the presenter. I mention this because some people's career path are quite literally dictated by the amount of talking they would want to do in front of an audience. At the end of the day, know that good communication skills, especially presentation skills, can dramatically enhance your worth as an engineer. Also, there are several ingredients which go into solid technical communication. We might do a separate video addressing those ingredients. Number 9. Some type of jobs are hard to get into without having specific background or experience. I would think that at least 90% of the entry-level mechanical engineering jobs on the market at any given time would be design-focused. By design-focused, I mean you are directly responsible for designing or improving the design of components. This point is worth some more discussion. Engineering is a service. Engineering serves its customers, internal or external, by providing products that meet some criteria. Design product engineers are typically responsible for delivering these products. Design product engineers typically have multiple resources at their disposal. If they wish, they can utilize these resources in their pursuit of a design. These services might include experts and consultants in various fields. The following are some of the services which a designer might typically utilize: design drafters, CAD specialists, manufacturing engineers, welding engineers, material specialists, seal design experts, piping engineers, CFD, fluid dynamics, analysts, FEA, structural analysts. These fields can be considered specialties within mechanical engineering. As a design engineer, one may be exposed to all or some of these fields. In some smaller organizations, well-rounded engineers may have to use skills from several of these disciplines themselves. But for most complex and sophisticated designs, a design engineer would need to refer to the relevant experts, consultants. Understandably, a job where you are acting as a specialist cannot be performed efficiently straight out of college, but one can still pursue their ambition of become a specialist right from the beginning of their careers. Here are some ways in which this can be done. Take courses in your field of interest at college or after graduation. Go to graduate school and specialize in your desired field. Seek opportunities to expose yourself to your target field. Maybe there are departments at work that one can work with. Seek training opportunities. Actively learn from experts. Number 10. Learning numerical analysis opens up a lot of opportunities. Numerical analysis is an interdisciplinary field. There is a link in the description where you can read more about numerical analysis. When we talk about FEA and CFD, we are referring to numerical techniques applied to engineering problems. While mastering the math behind these techniques is not essential for working as an engineering analyst, it can certainly help you gain credibility as an analyst. For this reason, taking courses in numerical analysis in general and specific numerical methods in particular can prove beneficial in opening up job opportunities which would otherwise be inaccessible. These courses may be taken at undergraduate or graduate level. So there you have it, 10 things I wish I knew back when I was in college. If you enjoyed this video, feel free to check out my website, featips.com, Also, I have published an ebook which has sold several hundred copies. It is a book on engineering in general, and structural analysis in particular. There is a free preview of the book available on my website. The link is in the description. I hope this video was useful for some of you. If you have any questions on this, feel free to post a comment or reach out directly at featips.help@gmail.com. Thank you for watching, and hopefully we will meet in another video.